Hi guys, I hope everybody's okay. Thanks for the one who came to the real conference within the room, and hi to all the others that are discovering our job right now. I'll be on my own. Unfortunately, Louis couldn't make it for the recording session, so I'll be alone. I'm Rouzoul, and I'm one of the co-founder of the Web Capsule. So Web Capsule, it all began as a collective of developers who adore visual programming tools. I'll mainly use visual programming instead of NoCode or low-code because we really like the code that is generated by the tools, and we build our solution upon them. We have, when we build apps for our clients, we have this philosophy that is 80% of the apps will be built out of visual programming tools to go quickly. And the 20% remaining will be through a coding session, so we can make unique apps and without compromising on what we deliver to the clients. We don't compromise on safety, on customization or performance, or even sovereignty. And that's how we build our apps. And what's a collective? So quickly, it's like basic modern pirates. We're a group of freelancers with shared roots during the projects. And instead of splitting the treasure that is gathered equally, we split them between the freelancers, depending on the time they spent on the app. We were invited to talk to you especially about our DevOps journey, because the philosophy, our visual approach we set up, it really depends on a DevOps approach. And we had to go through the no-code limits. And that's why we're going to talk a little bit about DevOps, that is the ungrateful discipline of devs, because when it's done well, it's invisible, and when it's done bad, it can go pretty wrong. So we'll see how we overcame the challenges that we faced because of this visual development approach. And we'll start by a quick overview. We'll go very fast on visual programming. There are conferences that will do it much better than we do, especially the Allegrias ones, but we'll focus on the limits we faced. And then we'll get back to the DevOps basics and see what the tools we set up and how it allowed us to overcome the limits we faced in the past. So first thing first, just a quick reminder about visual programming tools. What it allows you, I mean, for developers, for coders, it helps you build, it's make user management much easier because it's entirely visual. It helps you build API. So that's probably why we were invited by Apidays, so hello Apidays. And it allows you to build workflows with your business teams, so you can involve them in the dev of your apps. So it's basically nice to set up good workflow that automatize some time-consuming tasks. There are champions. There are multiple tools on the market with multiple assets. It's mainly split between 5 verticals. So you have automation, front-end, back-end, AI, data viz. They all have their champions. They are super nice tool, super cool to build microservices. It integrates pretty well in big infrastructures. But it's when you start to stack them that it becomes kind of hard. Even if all the most famous tools, they all have native API connections, when you start to stack them, you'll face several challenges. The first of them is the lack of security, because your data will be stored in each and every tool of your stack with various data management policies. So it's kind of hard to know where your data is at the moment and how it's managed. The second one is that it's unpredictable in terms of cache and performance. In terms of cache, because each tool has its own business model. So sometimes it depends on the power or the resources it requires. Sometimes it depends on the traffic of your app. And for the performance, you don't have many ways to control it. You really have to depend and to rely on the tools themselves. And if you track mistakes, you have to ask for the tool to correct them. And when they're stuck, it's tough collaboration because you mainly need as many DevOps as tools in your stack, because whenever you make a change within one of the tools, you have to check that it didn't destroy the rest of the stack. So that makes the collaboration kind of hard. But there are tools that are more integrated, and they are the ones that are used by the big companies. So you have the big guys, Mendix, Salesforce, perhaps. There are more integrated one, even more integrated one like Rouzoul. What they all share, unfortunately, it's basic poor dev experience. I mean, if you make a software engineer try to code with these tools, it won't be that happy. And you may have to turn to a consultant because it's always specific language. And it's a resource that is hard to find. And sometimes, most of the time, it's kind of costly. And the tools themselves are pretty expensive because they mostly rely on business model that focus on the number of users instead of the numbers of contributors or builders. So whenever you want to build an app for a small amount of user within the company, it's okay. When you want to have a large user base for your application, then it can skyrocket, the price can skyrocket. But these tools, they have two main advantages. The first one is that they are immortal. They have cash, so they will survive another year, even in times of crisis. And most of the time, they are all compliant with even the most restricted IT departments. So if we want our challengers to compete with these guys, they have to come clean. And come clean, we can take the example of Airtable, which would be nice. Most of the time, it comes from the product team that say, okay, I want to try this tool because it's super nice. And they have to go through a long editing process from the IT department to define if it's a good tool to use or not. And most of the time, it's a long editing process that generates frustration and to end up with a no from the IT department. And what the product team does is that they use it anyway. So it generates more shadow IT within your company instead of using these tools. And it's basically the same for the low-code, no-code, visual programming agencies that comes to the companies saying, okay, I have a great tool, I have a great project I want to build. They have to go through a long editing process. It's a commercial one for this time. They end up most of the time with a small MVP to build. And this is low revenue with no recurrent revenue because once it's done, then it's rebuilt otherwise. And so it's a huge commercial expenses for not a big of a return on investment. So to tackle these projects, we have to go back on the basics and solve our clients' problems. So it's product teams for the local agencies and even for the tools themselves that have a minority of large enterprise as clients, but that represents most of the cash that is generated. And we'll only use use cases to illustrate what we did. The first thing, we had to choose our champions, so the challengers, and we have to think as software engineers. So we wanted to have a stack of tools, all code available tools. So it's mainly open source, but sometimes it's just code available. You have tools from the backend. We like Directus a lot. We have tools for the front end. Plasmic is our champion. For automation, we found the 5 verticals we dealt with a little sooner. For BI, Metabase, and for AI, both Yamato and Mistral AI. What we did with these tools is we applied basically the same process we do with basic software engineering. We had our stack that we like a lot. We wanted to go to a no-code stack to go a little faster in the development of our apps. But once we used these stacks, we quickly reached the limits that we dealt with. And so we turned to this visual stack with code available tools, so we can build easily with the visual approach and custom them with basic framework that we already master. What we did is bring the best practices to this visual stack. So the first thing was to build a composable infrastructure, so we can gather all the tools within one stack and manage them as one big stack. So first use cases we can get is this is a project we have with a massive logistic player. He wanted to build a field survey with managed rights. So we used directives to manage the rights. Upon the big architecture, we used Keycloak, which is pretty nice to connect to the company's SSO. And we use all the best practices you can get in an infrastructure. So we build it upon SQL, so on the cloud SQL, on Postgre, sorry. We used, this is all gathered in one Kubernetes, and it's the whole WebCapsule is deployed on Google project. And what we needed was to custom one of the tools. So the customization was regarding directives. So we needed to integrate Survey.js. And what we did is, as we had access to the code, we could just integrate survey.js to the directives to end up with our great survey, field survey with managed rights. The cost of such infrastructure, so they are auto-scaled and they are kind of strong. It can go from $700 to $1,500. And it's a little cheaper if you go to AWS, I mean, for the same amount of services. This is another use case we had. It was with a young startup that worked with book editors. They wanted to have a specific funnel of acquisition for the clients of the book editors, and they needed to integrate AI within the marketing process. So they needed to integrate Python calls. So we built another node on N8N because we had access to the code, and then we customized the whole stack. We deployed it on AWS, the small part of AWS within the whole AWS account of the startup, and then voila, we had these tools that were deployed and entirely manageable from the infra to the code of the tools themselves. And this costs between $400 and $1,200, so kind of cheaper for the same service, basically, as what we had on GCP. We automatized this part for GCP and AWS. We are making our way to OVH, by the way. For the third use case, it's to illustrate how you can customize an infrastructure because you have access to the infra's code of this architecture. This is a marketplace. It's a big car marketplace. They needed to add BI within their architecture, so we simply had to add metabase or superset, depends on which BI you'd like the most, and it simply required deploying Docker within the Web Capsule, as we have integrated like a Dockerfile approach within the capsule, but we'll go on it a little later. And the fourth example was how to manage, because we talk about best practices. Best practices, it also concerned the environment management. So we had to build multi-parent stack environments from staging to production. We needed this because we worked with a public company and we had small sprints. It was like 2-week sprints. So we needed to deliver a production app in order to continue developing the app on the staging parts. So we had to manage how you can go from a staging app to a prod app. And we used basic Git flow. It was GitOps to allow a custom CI. So that's the CI from the Web Capsule, and how you can compose your infrastructure. So thanks to Docker. And this is the way you integrate tools like BI tools like Metabase or Superset. The tricky part was the DB flow, as most of the code, not most, the part of the code is in database, such as IDs, like users, role management. We had to manage the way to push these information from staging to production. So that was kind of tricky, but it was nice. It was a nice tricky point to tackle. We've seen the best practices we set up on the development of the development cycle, but we have best practices for the whole life cycle of the app, because once it's developed, it starts to live its life, and it requires real-time monitoring. As the source code is in-house, you can supervise it with basic tools, Datadog, Lighthouse for performance, CloudWatch if you're on AWS, or you can even use your own audit tools, as you can like connect to the infrastructure through our API. If you want to add some of the tests, that's no problem. And even if you monitor it well, you will unfortunately face incidents. You cannot miss them. There are mainly best practices that are set. The first of them is to manage the access rights in order to not let anybody who's not aware of the situation modify the app and destroy the whole job that has been done by the developer previously. If it goes wrong, no problem. There are backups and rollbacks. And in the worst case scenario, there are also disaster recovery plan if your app is destroyed, or if there is a problem on your architecture, it can be rebuilt somewhere else. Don't worry, it is managed. And even if the app management is going well, if we reach the end, this is not a big problem, because we'll be super sad, but it's normal, and there are no app legacy, as the best practices requires that you have access. I mean, our clients have access to the source code of both the infra as code and the tools, so you can maintain them. It requires only maintain the generated code, so packages, updates, and for the infra, it will be building another CI. If you don't want to use ours anymore, that's okay. But all these dev parts, we had to make it visual, because we've made our approach visual to ease the collaboration between the software engineer and the visual developers. So to bridge these two guys, we had to replace the intimidating CLI tools. It had to be visual. It has to start from the tools themselves rather than from a repository. Because if you want to ask a visual developer to open a command line interface or a Git repository, they might choke. So we have to think like themselves. And to foster the collaboration, we had to make it entirely visual. And that's what we did for the tool we built and we deployed to our clients. You start from a set of tools you want to build. So you pick a champions stack among multiple ones. Once you deploy it, so we build the infrastructure. We structure the Git repositories of each tools, and each of the infrastructures and the Git repositories can be custom as wished. We encapsule all the tools within two environments. So staging and production, and you have two ways to push new versions, either through the interface from the visual programming tools, or via Git for custom codes. And that you can do what our visual approach is, splitting between 80% of visual development and 20% of code. And all contributions are tracked and shown on the interface, so you can track who made a change and when he did it, he or she did it. You can monitor your app, of course. We integrated Datadog, so there are not many users because it was for the demonstration, but it could be, there could be much more traffic. It would be nice. This is a small RAM, but you can see it would be exactly the same if you use Lighthouse to monitor the performance. And to ensure that the collaboration process is okay, and to ensure a good pipeline of production process, you can manage the environments, the rights each developer will have on each environment and each tools that is on the stack. So yeah, that will be it for us. The first conclusion was thanks for DevOps. because we could turn to tools with good dev experience, which remain visual, built on standard language, so we could customize them pretty easily, as we've seen in some of the use cases, and at competitive prices, because you pay on a base of, well, it depends, it will be on projects or number of builders, but not on number of users. That's kind of nice. And with this DevOps approach, we make them immortal, because even if you decide to leave the web capsule or you want to live by yourself, then it's okay. You just have to maintain the code and the infra. And we made it compliant, because you can check all the IT checklist that is offered by the IT departments, because you deploy the apps on their own infrastructure. So if you're head of medium or large IT departments, or if you're a developer that struggles to introduce visual development within the company, don't hesitate to reach. You have plenty of information within our doc. You can find it on webcapsule.io. And if you want to contact us, we'll be very happy to discuss with you. And I wish you guys a pretty good day. And yeah, hope to see you soon. Bye.